104 stories up to the top of the tallest building in New York, being not only the highest, but the safest, the most innovative and beautiful skyscraper in America. This is One World Trade Center. Back in the days, the Twin Towers were considered state-of-the-art. The Twin Towers were crowded with people, but decades later, the serious incident happened: 9/11 attack. Architect David Childs watched the event of 9/11 from his office in downtown Manhattan at 8:46 a.m. The North Tower was struck by an airplane, then the South Tower was hit. Both buildings were in flames. He was certain that towers wouldn't fall down and the fire would be put out, because never has a steel structured building collapsed because of the fire in the history of steel structured buildings. However, they collapsed. Nearly 3,000 people died. Several months after the attack, David Childs started to think about designing a new tower at Ground Zero. It was the challenge of a lifetime to come up with a building strong enough and safe enough to be built on this site. As David Childs designed, Ground Zero was in ruins. Rescue workers were desperately searching through the rubble for the remains. While cleaning up more than 1,000,000 tons of debris, engineers discovered another disaster waiting to happen. The site is at risk of being inundated by the Hudson River only a few hundred feet away. Many people aren't aware that this site at one point was underwater. It was a landfill. Over time, landfill fully increased the tip of Lower Manhattan. What this means is that the site that was occupied by the World Trade Center is literally in water. To build the world's tallest towers on land like this, engineers had to find a way to keep the river out. They came up with an ingenious idea. That is the bathtop. The bathtubs are made using slurry wall method. The slurry wall encircled the World Trade Center complex like an enormous bathtub. A bathtub at the World Trade Center site was built within and essentially kept out the Hudson River. Kept out all the wet soil surrounding the site. The slurry wall was made up of over 100 panels, each one 22 feet wide and 7 stories deep. Going all the way down to fit below bedrock. Each section was excavated and filled with a gluey clay mixture called slurry, which keeps silty soil and water from getting in. Next, a 70-foot-long steel frame, weighing 22 tons, was lowered into the slurry-filled panel. Concrete slowly pumped into the panel. When the concrete hardened, they repeated the process over and over again, forming a massive underground wall. Once the wall was built, they proceed with the installation of tiebacks. These tiebacks actually hold the walls to the rod. Tiebacks are long steel rods that go all the way down to the bedrock to support the wall. After 9/11, it looked as if this enormous bathtub might have been weakened and could collapse. To prevent the slurry wall from collapsing, the debris was broken into pieces and removed. After removing all the debris, a new liner wall was built right in front of the original and new tiebacks were installed. There was a gaping hole in the New York City skyline, and no one can agree on how to fill it. Everyone had a different idea of a different vision of what should be there. David Childs, along with partners, began designing with strength and safety from the inside out, starting at the core. The core of a skyscraper is a backbone and runs up the center. It provides structural support and strength. Child's design for the core of this super tower will use one of the strongest, most fire-resistant materials, concrete. But this isn't just any concrete. This concrete needs to be so strong. It means going back to the lab to develop it. This is a concrete specimen that will be used for One World Trade Center. If you could set a cylinder and put a platform on it, 1,000 normal people under 75 kilograms standing on this cylinder. This concrete is made of sand, stone, and binding agents like lime or cement. Also, the recipe was made by using chemicals that keep the concrete moist without reducing its strength. Compared to normal concrete that is about 4,000 psi, this concrete can withstand loads up to 14,000 pounds per square inch. But strong concrete has its own challenges. It hardens quickly, so it's a race against time to get it into place before it gets set. Driver has only 90 minutes to get the job done. Concrete like an hour and a half to get the rod off. By 2006, this super strong concrete makes its own way to ground zero, where construction has finally started. Crews have less than an hour to pump it through an elaborate system of hoses, where it is poured onto a mold and secured with steel bars called rebar that gives concrete something to latch onto. The cores of Twin Towers were compromised on 9/11 because they were made of steel wrapped in thin sheetrock. Sheetrock was not strong enough to take that punching shear. At the point of impact, the stairs were destroyed, leaving nearly 2,000 people trapped above with no escape. That's why it's critical for One World Trade Center to have a super strong concrete core designed to avoid the tragedy of 9/11. At One World Trade Center, a one-of-a-kind structure is taking shape. 20 stories high, the podium base is designed to be strong enough to survive a massive truck bomb. The podium has thick concrete walls that are reinforced with large steel columns. Not only it is strong, it will look strong enough to be a deterrent. But David Child didn't want to create a fortress. He wanted to make the podium more inviting. He designed soaring entryways. Behind them, giant concrete blast walls protect the lobby. But Italian marble will hide their true purpose, and large openings will allow sunlight to stream in. Also, he decided to cover the podium with a kind of glass that reflects light like a prism. The glass will have to be cut in a way that could compromise its strength. As the core rises on the outside, One World Trade Center is starting to take on its distinctive shape. The podium is a square about the size of the original towers. At the 20th floor, the corners tapered in. A square becomes an octagon. Four sides become 8 interlocking triangles. Finally, at the top, it resolves in a square once again. To achieve this subtle shapeshift, Chaz turns to steel 45,000 of it. Steel sheets are carefully cut, welded, and shaped to make pieces that fit in a specific place in the building. Some of the largest are called nodes. They can be as large as 60 tons and stand 3 stories high. Nodes are giant joints that hold multiple pieces of steel together. They come in all shapes and sizes and make it possible for the building to shift form from 4 sides into 8. And they also helped redistribute the weight as the building rises. It has 3 categorized factors of stability. It has stability at steel frame, shape, and cotton wool. Story after story, the steel frame goes up, the concrete core which gives One World Trade Center its strength follows several stories behind. Until the core catches up, the steel frame needs stability. To solve this problem, cargo containers were placed between the steel beams and outfit them with tables and chairs where construction workers go on breaks. As a result, container can also solve the problem of taking a substantial amount of time for workers to move around the building up and down for lunch. By the 10th anniversary of 2011, the super tower had reached 80 stories, and huge panels of glass were starting to cover the exterior. Over the next several years, these enormous panels of glass, called the cotton wool, will make One World Trade Center impermeable to the elements of its surrounding, except for one: wind. When wind hits a rectangular skyscraper, it pushes against the flat surface and creates turbulence around the sides, and that causes the building to sway. But One World Trade Center's unique design means the wind is not a problem. Instead of hitting a broad, flat surface, the wind flows around the tapered corners in a more gentle way, and that reduces the turbulence and the sway. On the exterior of podium base, the safety guaranteed glass panel which will not shatter into sharp pieces, has finally been installed to its place where it had to be. And for the few months, thousands of panels of glass had covered the entire base of the building. But unlike the cotton wool verb, they were not flat. In order to let air in and out of the mechanical systems behind them, the panels open up. Just before winter descends on the New York harbor, a barge makes its way down the Hudson River past the Statue of Liberty. It is carrying precious cargo. The first 9 sections of the One World Trade Center's spire. It has taken a month for them to make their way from Quebec to their final destination, Ground Zero. The next morning, the heaviest piece, the 67-ton base, is lifted to the roof. Over the next several months, the remaining 15 sections of spire are lifted to the top of the super tower and assembled. And finally, the last 2 sections of the spire, including the beacon, are lifted to the ridge, a symbolic 1,776 feet. For the thousands of workers who built this tower, it's a moment to savor. On the 12th anniversary of 9/11, construction at One World Trade Center was at the tip of the end. Ground Zero was restored by the essence of the constructional engineering. Life, safety, and calmness has returned to Ground Zero. It has become the meaning of restoration and overcome threat through the revolution of construction. And the way Ground Zero has been designed and built makes one thing certain. Construction can mean something more than just building a building.